Hi, and welcome to this video for question 8 for paper 1 of the Leaving Cert Ordinary Level Maths in 2020. If you want a copy of the notes I'm working off, just send me an email at shanetry@gmail.com. And if you subscribe, you'll get access to more playlists. Okay, so we're on question 8 here, which is one of the longer questions in section B. Now it's worth a whopping 55 marks, so it's worth taking your time. And I suppose it's worth saying, make sure when you're doing the math paper, you've timed it so you're not short on time when you get to the last few questions. And they say here, a swimmer is on a starting block at the beginning of a race. Okay. When she dives off the block until she resurfaces, the level of the swimmer relative to the level of the water is given by this function. So the scenario doesn't matter. This is everything. Now I prefer to write the function notation with the input written much smaller, so you don't fall down the mistake of thinking this is h times x. H of x is her height relative to the distance. Okay, so that's all it means. Now I don't want to go clutter the diagram up too much. If you notice, this is a quadratic. Okay, so it'll have a shape, something probably like you think about it, a person jumping off, they go down into the water and back up. So the water level is somewhere. Okay, and then they usually they start kicking whatever and they swim off and they do their thing. They're saying that in the function x is the horizontal distance, so your distance going across from the starting block, and your h of x is the depth, for lack of a better word, or your x and your y. Now they're saying that this function describes the movement for the first 12 meters. This x in the doesn't matter, it just means it can be any number, and the units are meters. So it says find the height of the block above the water. So this function has two unknowns. It's the distance, the horizontal distance, and the height. So all you've been asked there is find the height of the block above the water. And you have to realize then that, look, if this person is ready to dive, okay, that's where they're standing. Okay, back. What's their horizontal distance right there? That's going to do it again, I think. It's 0. Okay, that's their starting point. So really all you're doing is finding what's h of 0. So if you think about it, if you put 0 in everywhere you see x in a function like this, okay, what's going to happen when you put it to the calculator? Going to cancel, because anything times 0 is 0. A quarter times 0 is gone, and you're left with just 3/5. Okay, and that's in meters. So think about it, like, that's what, 60 centimeters? Yeah, that makes sense. Even look at the image. Like, is that about 60? A little more than half a meter. Yeah, okay, great, but cool. Yeah. Now, when I did it, I put in both the 0 and the 12. Now I didn't need to. Okay, don't know why I did it, to be honest, but whatever. It didn't matter, and I took away, in a sense, I didn't need it. No, actually, to be honest, none of this is needed. Okay, this was my answer down here. Now the next one, part B, part 1, says show that the swimmer is on the surface of the water. So that's where the height equals 0. Okay, remember, this is representing an x and a y. Okay, that 3/5 is the starting point. This is 0, and that's the surface of the water. Okay, so your shape is something like that. Now, so when that is equal to 0, if you remember our function, actually, let's go straight to the answer. That's the function we were given. They're telling me when that is 0. So if I make that realization, okay, and put in my 12, okay, do I get an answer of 0? So I put my 12 in everywhere I see x, because they tell me to do that. Put to the calculator, I got 0. So my statement is, I've shown that, I've proven it. Okay. Now, if in a sense, if you're doing that, you don't know what else to do. Okay. You could have put this whole thing equal to 0 and solved it. Okay. And got two answers. That maybe would have been a roundabout way of doing it. We're going to have to do that in the next thing. So it's much for muchness. But part 2 here says find the horizontal distance. Okay. So the x value in meters. from the starting block to the point where the swimmer enters the water. Okay. Now, there's a lot going on here. Okay. If you don't really understand what's happening, this can be a tricky question. Okay. Even when you do understand what's going on, it can be a tricky question. But if you can cop that where the swimmer enters the water is the x-axis. I think I have the original diagram back here. This is actually a graph of the function. Okay. So that's your 3/5. Okay. That's where it enters the water. So our answer is going to be 2. Okay. I think it's going to be 3 if I look at it more closely. So I have to make that realization. This is my function. I'm looking for when the h of x is equal to 0. So this is an important thing to concept to get in maths. If these two things are equal, well then so are these two things. And once you make that realization, you can put them equal. Now, once I put them equal, okay, I've created some problems. This is a messy equation. But can I make it simpler? I don't like the fractions here. If I multiply every term by 60, that's a common factor. So 60 times 0 is 0. Now 60 times 1 over 60, they're cancelled. Okay, you're basically multiplying this by 60, this by 60. I'll put them in brackets just so it doesn't make sense. This by 60 and this by 60. So the 60 here is cancelled, so you're left with 1. Now this 4 to 60 goes 15 times. Okay. And this 5 and the 60 goes 12 times the 3 is 36. All I've done there is removed the denominators here, the bottom numbers. And I've multiplied across by a common factor. The simplest number all three of them will divide into is 60. I could have gone 120. Okay. It would have worked too, but it would have just made more problems down the road. Now, once I have my quadratic, I can solve this. And I can use the minus b plus or minus the quadratic formula. Or I can just use the fast method. Now, the way I would have learned this in school is, okay, there are different methods for doing this. I take the number at the end, 36, and then the number in front of the x, so the minus 15. And I open up two brackets, okay, and I write x in the first, x in the second, again, what doesn't matter. And I'm looking for what numbers will multiply to give 36, okay. Now, it could be 12 times 3, could be 6 times 6, could be 36 by 1. Now, of those, which numbers would add to give negative 15? Now, none of them can, until you realize that, wait, if I had minus 12 times minus 3, that would be plus 36, but minus 12 minus 3 would be equal to minus 15. And they're my two answers. So minus 12 and minus 3. Now I've got the factors, but the value of the factors, I can take each factor, write equal to 0, and then solve it out. So bring the 12 across, negative 12 becomes positive 12 going across the equal. Do the exact same thing with the other, okay, and that's here, and you get x equal to 3. Now, they cross, if I go back to the graph here, they cross the surface here and here. Now, 12 is not the first time. It's when they come back up. 3 is when they enter the water. Okay, so that's why I pick x is equal to 3. Job done. Okay. Now, part C, part 1. So this is a long question. We're already on 8 minutes video, so I apologize. And this is things, we have our function. Now it's weird, okay, but they're saying now find a derivative of that. That's what this notation means. I'm going to go to my answer here because it's prettier. There's my function. Now, if I apply the power rule, and now this infographic you're not given, but it is what the power rule is doing in words, okay? And I often I learn off these two-step method. And the two-step method says multiply the power by the number in front, whatever it is. Now, 2 times 160 is 130. Okay, now that's calculator will do it for you, so use it. Now, step 2 of the power rule says take 1 away from the power. So 2 take away 1 is 1. And this first term has been differentiated. Now I need to move on to the second term. So same thing, there's a power of 1 there. We don't say it, but there is. Power by number in front. 1 times negative a quarter is negative a quarter. Now what's happening to the power then, okay, is you're taking 1 away from the power. So 1 take away 1 becomes 0. And we learn off in differentiation that anything to the power of 0 is 1. So it effectively becomes minus a quarter times 1, which is minus a quarter. Now the last term, the plus 3/5, any number when differentiated always turns to 0. Okay. Effectively, what's the slope of this? Now, if that was 3/5, what's the slope of the line there? Well, it's not going up, it's not going down, it's 0. Okay. So when you differentiate a number, it always turns to 0. So this new function is the derivative of our original h function. And for lack of a better word, this gives us the slope at any point, okay, on this original function, which is a really important thing. Okay, again, a bit maybe above the pay grade of leaving or past maths, but if you go down the roots of engineering, science, really anything that studies change, slopes are really, really important. Okay, can't undersell it. Now, part 2 there says use your answer to part C1 to find the horizontal distance x in meters from the starting block at which the swimmer reaches her greatest depth. I'm even tired after reading it. Now, the answer's right in front of us, so it's a bit whatever. This is max and mins. They're looking for the minimum in this case. Now, if they said the greatest height, be a maximum. But this is a quadratic. Let me clear off the fluff here. Okay, this original shape is a quadratic. A quadratic either has a max or a min. Okay, now a cubic equation would have a max and a min. Okay, and that gets a bit more complex. So if we're looking for the max and min, there's kind of a 4-step method. Step 1 involves differentiating. Now we've done that, so I've just written that out here. Now step 2 says that at the minimum, the slope of your function is equal to 0. So I'm just stating that here. And we already had this logic a minute ago. These two things are equal. So why aren't these two things? Okay. Now once we make that realization, can't I put them equal to each other? And I've done that here. If you see now, this is an equation of one unknown. What do you do when you see an equation of one unknown? You solve it. Simple as that. Bring this across. Okay. It was subtracted on the right, becomes the opposite or positive on the left. And then you can do a few things here, but all I've done is cross multiply the 30 by the 1, and I get 30. Okay. Now this x by 1 becomes 1x. You could have put a 1 there to make that maybe more clear. Now x is equal to 30 over 4, which can be simplified to a decimal if you want, or you can leave it as 30 over 4. That's 7.5, and I probably should have put in there the units of meters. I probably should have, just not 100% sure, without looking at the market scheme. Now in saying that, okay, it's always worth, and if you want to email me at shanetroy@gmail.com and ask me to, I'll include the market schemes. Okay, I'm trying to drag it across, but the market schemes are very useful. Okay, you see the suggested answer and the marking and just some general things about what you need to do. Now, if you're not very comfortable with maths, then I wouldn't be wasting my time with market schemes. Waste that time if that's a waste on practice. But if you're going for an A and you want to be, fairly sure of that, I would suggest you have an understanding of how the market schemes work. Okay. So with any question, be even this one here, there's on the market scheme, there's 5 marks for it. It's on the C scale. So you have your 0 marks, so no merit, no partial, mid partial, high partial, and then full marks. Okay. Now sometimes there's a band of 5 or less. It depends on the question. But knowing that, you're kind of going, how can I get the minimum marks? If I do a fairly decent answer, but I mess it up at the end, I'm going to get the high partial. If I do a good answer, include the units, if they're appropriate, I'm going to get the full marks. Now, the thing is, at the end says, find the greatest depth. So we found the x value, for lack of a better word. They're asking us to find the y value. Or in this case, it's the h of x value. So we can use our original equation, which gives us the depth. Okay. Now, we want to find that at the minimum point, which is the 7.5. Put that through the equation, use the calculator, and I got 27 over 80. Could have gone decimal. It doesn't say what to do. Okay. Now, the answer comes out in the calculator is going to be negative, but that just means it's a depth. Okay, so you can ignore it. Okay, because we understand the logic of what's happening here. That's it. So this is effectively part 2 and 3. There are your max and min question, which look I'd be expecting if I was looking at the Leaving Cert in 2021. Now part D here, it's kind of a head wreck here. Knackered, at least I am so far. We're already at 15 minutes, and there's a lot of reading there. I'm not going to read it, but you have now. Michael Phelps is a famous Olympic swimmer. Okay, won a crap ton of gold medals. But between 0 and 50, it takes him that many seconds. Okay, and the next 50 meters is a little bit longer, slowing down, longer and longer. It makes sense. Okay, so what was the increase in his time? Now, if you were looking at this one, let's just test it. If I have 28.5 divided by 24.85 multiplied by 100, do I get 14.7? So like you're just kind of testing the logic here to see does it work. Now if I clean that off, so 28.5 divided by 24.85, multiplying that by 100 to convert to a percentage, and I get 114.68. Now to one decimal place, that's 114.7. So I get an answer there of 114.68, which to one decimal place is 114.7. Now, this can be broken into 100% and a 14.7. The 100% is the original time plus about almost 15% extra. Okay, so you're just trying to identify that increase. The 100% is the same time. It was increased by 14.7. Now, if we do that again, the exact same thing, so 9.333 divided by 28.5. Okay, now I did it, I got 1.0291. Multiply that by 100, I got 102.9. So the increase is 2.9%. And I've recorded that on the table. Then I do the 30.68 divided by 29.33. Multiply that by 100, and I get 4.6. So it's the same thing again and again. Once you get the logic and you're given almost given the answer to the sample calculation, so you can test it to see what works. You can divide this by this, you can do it either way. And then go, which one gave me this answer? And whatever way it works for you, do it again, and you get there. And that's part D, part 1. Okay. Now part D, part 2 is the same thing, but this time you know what the percentage increases were. You've just worked them out. And whatever answers you got in the previous one, even if they're wrong, will be accepted as fully correct in D, part 2. So you're given 25.01. Now you're told that's a kind of fictional time. If you just notice, that's different than the time given in part 1. Okay, so this is a different swimmer. And that's what all this blurb is saying, is different swimmer. And you have the 25.01. Now you're multiplying that by 14.7%. But remember, there's also the 100, so you're multiplying that by 114.7%. And that gives you an answer. I haven't done the next page. And I got 28.69. So I wrote that down here. Now that 28.69 feeds in, so that's increasing by 2.9%, which is 100 plus the 2.9%. So I'm multiplying that by 102.9%. I got 29.52, and that goes in here. Doing it again by 4.6. Again, it's 4.6% plus the 100, so it's 104.6%. Okay, I got 20.877. To two decimal places is 20.88. I've made an error there. That's true. Okay, I made an error there. Don't know why I made an error, but I have. Okay, and that'll compound here. I wonder why I made an error, because the marking scheme, I thought I would have checked the answers against it. D part 1. 20.89. D part 2. Okay, I'm off by a significant amount. So I'll have to check what's wrong there. Just give us a second. I've just noticed a few things, okay, and one of them is that this shouldn't be 20, it should be 30, okay, and this is an error, okay, this is 20.87, this should be 30.88. So this calculation is wrong because that should be replaced. So it should be, I'm going to go with 114.10, just off my head. Now realize then, I haven't actually finished the question. Okay, it says find the difference between this swimmer's finishing time and that of Michael Phelps. So it's not just this table filling in. I have to go back to 153.36. Okay, and now that's, if I go on 153.36, so 1 minute 53 seconds. Okay, that would be 60 and 50 would be 113, okay, seconds roughly. Okay, now if I take away the 104, there is decimal places here, but that's what 6 and 3 is 9 seconds difference. So I haven't achieved the 10 here because I didn't finish the question. Probably didn't get the 8 because there was an error. Not obviously sure what the marking scheme would say about that error. Okay, although I am looking here, and again, if this, I'm almost finished the question, so feel free to knock off if and try it yourself again. The marking scheme here says if I get the high partial if I have 3 correct split times found. Okay, so 1, 2. Now I had this one found, but the calculation was wrong. So I've only found 2. So I would have got the mid partial, which is annoying, but I didn't finish the question. If I had finished it and I got 2 of them right and the correct finish based on my numbers, I would have got the marks. So look, I have a bit of editing to do on this document. Anyway, that was question 8. Apologies for the kerfluffle there at the end, but look, shitty sale. And this is the question 8, paper 1, 2020, ordinary level leaves or maths. If you want to copy these notes, the corrected notes, send me an email at shanetroy@gmail.com. And if you click subscribe, you'll see access to other videos with different playlists of different years of maths. Okay, thanks very much.